this is where we ended the last lecture. So we learned how to create an initial design from a given set of requirements. So before I start today's lecture, I must mention that in the last lecture I forgot to add an additional attribute for dependent, which should be employee, so that you have a way to link which employee has dependents or which dependent is depending upon which employee. So anyways, with that out of the way, let's start today's lecture. So what we learned in the last lecture was the initial design, and it is typically not complete. Some aspects of the requirements will be represented as relationships. So ER model or entity relationship model has three main concepts. The first is entity, which we've already learned about, attributes, and finally relationships. So the R in ER stands for relationship. So today in this lecture we are going to focus on relationships. Anyways, before we do that, let us briefly review what we've learned so far. So we learned that to represent an entity we use a rectangular box, and we always type or write entity in uppercase letters. Okay, then we learned about attributes. So the first one that we learned was a simple attribute. So simple attributes generally take just one value. An example of a simple attribute could be, suppose, salary for an employee entity. So next we learned about composite attributes. So composite attributes were attributes which could be further broken down into other components. So suppose it could be something like license plate number, which could be further broken down into or expressed in terms of state and your actual plate number. So the state and the number makes up your license plate number. So this was a composite attribute. And finally we learned about multi-valued attributes. So multi-valued attributes are those which are represented using double ovals. These attributes can take more than a single value. Suppose in the case of department, it can have multiple locations. So furthermore, we learned about a specific type of attribute, which is key attribute. So a key attribute is one which always contains unique values. So suppose license plate number is a key attribute, and we always underline key attributes. So a composite attribute can be a key attribute as well. At the same time, a simple attribute could be a key attribute as well. So an example could be SSN or social security number. So that is basically all that we had learned in the last lecture. So today let's learn about relationships. So a relationship relates two or more distinct entities with a specific meaning. So an example would be employee John Smith works on the product X project, or employee Franklin Wong manages the research department. So the relationship between employee and a project is that an employee works on a project. So works is a relationship here. And then the relationship between an employee and a department is that an employee can manage a department. So this manage is a relationship between the two entities. So this again, let's read this line that says a relation relates two or more distinct entities with a specific meaning. So a relationship basically is an association between two or more distinct entities. However, we'll see how it can also be between the same entity as well. So relationships of the same type are grouped or typed into a relationship type. For example, the works on relationship type, in which employees and projects participate, or the managers relationship type, in which employees and departments participate. So this is talking about the participation between the entities. So you'll understand this a bit better when I explain you with notations. So next up we have degree. So the degree of a relationship type is the number of participating entity types. So participating entity types means how many entities are involved in a relationship with, say, one another. So suppose manages and works on are binary relationships, in the sense that an employee has a relationship between a department, and that relationship is that an employee manages a department. At the same time, an employee has a relationship with project. That relationship is that an employee works on a project. So you see, every time we have two participating entities, one here and one here, again one here and one here. So when you have two participating entities in a relationship type, it's called a binary relationship. And the degree is the number of participating entity types. So suppose if you had another entity here called D, you'd now have three entities participating in a relationship. So you could no longer call this a binary relationship. Instead, it would be called a ternary relationship. Anyways, so this is an example of a n:1 relationship. So n:1 means there on one side you have n types or n participants and on the other you have just one participant. So let's take a look at an example. So you can have one employee working in one department. So suppose employee 1 works at CSC department, and suppose you have a EEE department as well. So you have one employee working at just one department. You cannot have employee 1 working in the, so I think a better example would be if I use BBA. So you, on a realistic scenario, you can't have employee 1 working in the BBA department as well. So this type of requirements will be specified, or you may have to infer them from the questions that you are given. Anyways, so employee 2 could be working in the BBA department, but employee 2, since he's working in the BBA department, he cannot be working in the CSC department. At the same time, you can have employee 3, employee 5 working in the CSC department, employee 7, employee 9 working in the BBA department. So as you see, you have multiple employees working in a single department. So this is a n:1 relationship, where if you take a look at this diagram, you can see that employee 1 works for department D1, and the same time employee 3 works for department D1. Again, employee 6 works for department D1. So you can see that there are multiple employees working in a single department. But you'll never have a case here where one employee is working on two departments. As you can see, we do not have anything like this where, say, employee 1 is working on department D2 as well. So this type of relationship where you have n participants on one side and just one participant on the other is called a n:1 relationship. So now let us take a look at an m:n relationship. So as you can guess, in an m:n relationship, you have multiple participants on both sides of the relationship. So let's take a look at the works on relationship, so which was between employee and project. So let's start with employee. As you can see, employee 2 works on project P1. At the same time, employee 2 also works on project P4. So this means on here, on this side, if you were to take a look at it, you could denote that one employee can work on multiple projects, right? So now let's take a look at the other side. So let's view project 3. So as you can see, on project 3, employee 3 is a worker. Again, for project 3, employee 4 is another worker. So here you can see that on one project you can have multiple employees working on it. So therefore we're calling this an M:2N relationship. So relationship type is the schema description of a relationship. It identifies the relationship name and the participating entity types. It also identifies certain relationship constraints. So we'll look at constraints too formally a bit later. Then we have relationship set. So a relationship set is the current set of relationship instances represented in the database. So it is basically the data that is actually present in a relationship. So it is also known as the current state of a relationship type. So this is basically the same difference which was between a schema and database state. Only the schema here is basically of that of our relationships, and the state is of our relationships as well. So in the previous figures displayed the relationship sets. So let's now take a look at how we can represent relationships in an ER diagram. So relationships are represented using a diamond-shaped box, and the participating entity types are connected via straight lines. So suppose if you had an entity, employee, and another entity which was, say, project, the relationship between these two entities would be shown with a diamond-shaped box like this, and there would be connecting lines between the entity and the relationship. So that is how you represent a relationship. So now that we've somewhat learned about relationships, let us take a look back at the first requirement which we analyzed, and this time try to find out the relationships between entities. So in the last lecture we found out that department was an entity and it had attributes such as name, number, and see this line, each department has a name, number, and an employee who manages the department. So employee was what? Another entity. So as you can see, between department and employee we have a relationship, manages. So this is our first relationship that we've identified from the set of requirements. So furthermore, we keep track of the start date of the department manager. A department may have several locations. Okay, so moving on to the next requirement, which says each department controls a number of projects. So again, from the previous analysis we know project is also what? Another entity. So as you can see, there is a relationship between department and project, which is controls. A department controls a number of projects. Then we have some attributes for the project. So let's take a look at the employee. So again, employee is a entity and it has the set of attributes given here, such as name, number, address, salary, etc. So again, read this here. Each employee works for one department but may work on several projects. So the ones that I've highlighted in green are what? Entities. So as you can see, between employee and department there is a relationship which is works. Again, between employee and project there is a relationship called works on. So I'll just erase this and make it works for better differentiation. So employee works for department as well as employee works on projects. And we also keep track of the number of hours per week that an employee currently works. And again, we also keep track of the direct supervisor of each employee. So as you can see here, employee must have some sort of a relationship with itself, since we also keep track of the direct supervisor. So supervisor is what? Another employee, right? So there must be a relationship between a supervisor and an employee. Lastly, we have this: each employee may have a number of dependents. So again, between employee and dependents there must be a relationship, and for each dependent some attributes are given here. Okay, so let's see how many relationships we've identified. So 2 from here, 3, 4, and there should be another one here which was between employee. So let's just write this down. We have 1 here, 2 here, 3 here, 4 here, and the relationship between employee with itself, so 5 here, and between employee and dependent. So in total we've identified 6 relationships, right? So these are listed here, and all of these are binary relationships. Degree with a degree 2, which means that there are 2 participating entities. So this is what the final diagram would look like if you were to correctly design from the requirements given earlier. So in the refined design, again, if we go back to our previous design, as you can see, some attributes from the initial entity types have been refined into relationships. For example, in the case of department, we had manager as an attribute, but here manager is what? Manager is now a relationship between, so if you let me highlight this, manager is now a relation, basically managing is a relationship between employee and department. Previously this relationship was being denoted in the form of an attribute. So again, works on of employee was also denoted as a what? Attribute. So here you can see that instead of works on, I wrote project here. Instead, project should be an employee should have a relationship with a project entity. It should not be present as an attribute. Finally, we have again department of employee works for. So again, I wrote department as an attribute here, where instead it should have been a relationship between employee and department. So at the same time, more than one relationship type can exist between the same participating entity types. So this means there can be more than one relationship between the same participating entity types. So an example would be, say, suppose you have employee here who manages a department. At the same time, you can have employee here who works for a department. So as you can see, there are 2 relationships here. That is basically what it's saying, that you can have more than one relationship type between the same participating entity types. But these relationships, both of them have different meanings. So now let's talk about a recursive relationship. So a relationship type with the same participating entity type in distinct roles is called a recursive relationship. So an example would be the supervision relationship. So employee participates twice in 2 distinct roles: supervisor or boss, and supervisee or subordinate role. So again, if you take a look at this requirement here, it was saying we also keep track of the direct supervisor of each employee. So each employee must have a boss, and who is that boss? Basically another employee. This means there should be a relationship between employee with employee, and that relationship should be what? Supervision or supervises, whatever you want to call it. So at one end you have an employee acting as a supervisor or boss, and on the other side you have an employee acting as a subordinate or so on the other side you have an employee acting as a subordinate, right? So this type of relationship where you have the same participating entity type is called a recursive relationship. Okay, so each relationship instance relates to distinct employee entities. So one employee in supervisor role and the other employee in supervisee role. So that is what a recursive relationship is basically. So how do you display a recursive relationship? So again, both participants are the same entity type in different roles. For example, supervision relationships between employee in the role of supervisor and another employee in the role of subordinate or worker. So in the following figure, let's take a look at it. So as you can see, the first participation role is labeled with 1 and the second participation is labeled with 2. However, in your ER diagram, you'll need to display the role names. So by role name, I mean who is the supervisor and who is the supervisee. So let's take a look at what it has done here. So here basically they're using 1 to denote the supervisor role and 2 to denote the subordinate role. So let's trace a employee. So here I think a good option to trace would be employee 1. So as you can see, employee 1 is supervisor of employee 2. How do we know that? Because we have a 1 here, and 1 means what? Supervisor role. And for employee 2 we have 2 here, which means subordinate. So this means employee 1 is a supervisor of employee 2, or conversely employee 2 is a supervisee of employee 1, right? So again, let's take a look at another example. So as you can see, employee 1 is again acting as a supervisor since it's 1 here, and employee 3 is acting as a subordinate, right? However, now take a look at employee 5. Employee 5 here is acting as a supervisor, and employee 1, who was previously acting as a supervisor, is now acting as a subordinate. So I can write here employee 5 is a supervisor of employee 1, right? So that is basically what a typical recursive relationship looks like. And again, it is important to note that in your ER diagram you should display the role names like I did here. So you should write subordinate here and supervisor here. So now let's talk about weak entity types. So weak entity types are those entity types that do not have a key attribute. So again, key attribute was an attribute that always possessed unique values, right? So a weak entity must participate in an identifying relationship with an owner or identifying entity type. So a weak entity basically cannot exist solely on its own. It must participate in a relationship which is known as an identifying relationship with its owner entities. So if a weak entity does not have a key attribute, how do you identify it? So suppose for the in the case of an employee, so let's talk about key attributes a bit briefly. So suppose in the case of employee, if you have multiple employees stored as table data in a database, so you have name A here, P here, and again A here. So obviously you can have two employees with the same name, but they will all have different SSNs, right? Since SSN is a key attribute. So in this way you can specify which one of these employees you are talking about using SSN. However, in the case of weak entity, an example of which was the dependent. So in the case of weak entity, I'm saying there are no key attributes. So how do you identify a weak attribute? That is the question. So weak entities are identified by a combination of a partial key of the weak entity type and the particular entity type that they're related to in the identifying entity type. So what could be an example here? So if we go back to our previous requirement, we have that each employee may have a number of dependents, and for each dependent we keep track of their name, sex, birth date and relationship to the employee. So dependent is a weak entity, right? So employee participates in a relationship with dependent, right? So let's write dependence of okay. So for employee you have a key attribute which was what? SSN, alongside other attributes such as name, address, salary, etc. But for the case of dependent you have something like name, sex, and what else was there? So you have name, sex, birth date, relationship to the employee. So name, sex, birth date and relationship to the employee. So none of these are capable of being unique. So you can obviously have a single employee who has suppose two sons. So if your relationship is son, you can obviously have this value repeated. Again, you can have the same sex. So for example, both your an employee could have both children as sons, which means that both of their sex would be male, right? Again, suppose an employee could have twins as his children or her children, which means their birth date would be suppose identical. So basically none of these are on their own capable of being unique. However, if you take a look at the name, so suppose an employee would obviously never name both his or her children with the same name, right? Suppose if his first child's name is John, his second child's name will obviously be different. Suppose something like Smith, for example. However, this dependent entity does not contain the entries for just one particular employee, right? It contains entries for other employees, right? So other employees could also have children whose name is John. So again, name is also not capable of being unique on its own. However, we can say that for any given employee, it will never happen that both his or her dependents have the same name. So in that sense, name is what is called a partial key. So as you can see here, a dependent entity is identified by the dependent's first name and the specific employee with whom the dependent is related. So name of dependent is partial key, and dependent is a weak entity type because it has no key attributes, and dependent and employee is its identifying entity type via the identifying relationship dependent of. So again, let me repeat that for a single employee you can never have dependents that have the same name. However, when we are talking about the dependent table as a whole, you can obviously have repeating name values in it. Therefore, we are saying that dependent's name is a partial key. So how would you identify a specific specific entry or row from a dependent table? Well, you're going to have to combine the primary key of the identifying entity. So the identifying entity for dependent is employee. So employee is known as the identifying entity, and dependence of is known as the identifying relationship, and dependent is what's known as a weak entity. And here we have name, which is what? A partial key. So the way you identify weak entities are via a combination of their owner or identifying entities key attribute as well as their partial keys. So a combination of, suppose, employee SSN and dependent name would be used to identify any specific entry in the dependent table. So I hope I have been able to make this clear. So we finally have constraints on relationships. So these are of two types. The first is cardinality ratio, which specifies maximum participation. So this means how many of your entities are going to participate in the relationship. So let us talk about a previous relationship that we discussed before between employee and, say, department, right? So according to the requirements, it was clear that one department would have multiple employees working on it. Therefore, this is a 1:n or n:1 relationship, and that is basically how you represent cardinality ratio in your relationships. So an important thing to note is that you should always specify the kind of relationship that's between your entities. So suppose the relationship between department was that an employee works for a department. So you should always specify the relationship by writing something meaningful. And then we also had m:n relationships in the form of employee and project. So we had a scenario where one employee could work on multiple projects at the same time. One project could host multiple employees. So this is basically a m:n relationship. And suppose let's call this works on. So this is basically what cardinality ratio specifies, that how many of your entities are participating in the relationship. So note that this specifies maximum participation. So this means when you have a 1 here, you cannot have more than one employee participating in a department. I mean more than one employee participating, more than one employee working at a single department. So whatever you write here means maximum. So next we have existence dependency constraint, which is also known as minimum participation and sometimes also called participation constraint. So what does this specify? So first up we have 0, which means optional participation. not existence dependent. So an example could be, suppose an employee may or may not manage a department. So previously we talked about another relationship, which was that an employee can manage a department as well. So suppose a single employee manages a single department. So an employee could manage a department or not. So it's not necessary that every employee will manage a department, right? However, so then let's take a look at the next participation constraint, which is one or more, and this is mandatory participation, existence dependent, and it is denoted using double line. So this means the participation is mandatory for an entity. So it's not necessary that every employee will manage a department, but every department has to be managed by an employee, right? Therefore, there should be a double line here, and this double line indicates mandatory participation. Basically, you cannot have a department without it having a manager. So these are basically the constraints on relationships. First we learned about cardinality ratio, which is basically maximum participation, and then we learned about participation constraint, which specifies whether an entity has to participate in a relationship or not. So now let's talk about attributes of relationship types. So a relationship type can have attributes just like an entity. So an example would be, let's take a look at the requirement here, which stated each employee works for one department but may work on several projects. So let us try to create a ER diagram for this specific requirement. So you have on one side employee, which has a number of attributes such as SSN, name, etc. Right, and each employee may work on several projects. So let us create a relation and let's call this works on project, and project is an entity. We've already established this in the last lecture. So project also has a number of attributes, such as each project has a unique name. So name is the key attribute for project. It also has a unique number and is located at a single location. So these are some of the attributes of project. Okay. So here, now read this requirement, which states we keep track of the number of hours per week that an employee currently works on each project. So before we do that, let me again go back to what we learned before here. When we talked about cardinality or maximum participation. So here we were able to establish that the relationship between an employee and a project is m:n. That is, one employee can work on multiple projects. At the same time, one project can have multiple employees working on it, and therefore we ended up with an m:n relationship like this, right? So now we've also learned about, the existence dependency constraint or minimum participation or participation constraint. So now the question is that, can an employee exist without working on a project, and can a project exist without having any employees? So by just common sense, you should be able to say that you cannot have a project without any employee working on it. So a project must always have employees working on it, right? So from common sense, we can say that it is mandatory participation for the project entity. So therefore, I'm showing it by a double line. Okay, so now again, so here it says each employee works for one department but may work on several projects. So from this we are able to establish that an employee may work on one or more than one project. However, this also infers that an employee must work on a project. Therefore, I am using a double line here as well to denote that you cannot have an employee not working on any project at all, because the role of an employee is basically to work on a particular project, right? So here you have maximum participation, which we are showing using the double line. So now what about attributes? So if we read this requirement here, it says we keep track of the number of hours per week that an employee currently works on each project. So an employee may work on a number of projects, but you have to keep track of the hours worked on each project. So let's try adding the hours worked as an attribute to project. So I'll call this hours worked. Okay, now would this be a correct solution? Well, if you think about it, you can have multiple employees working on a single project, right? Like this, have employee 1, employee 2 and employee 3 working on a single project. However, if you think of project as a database table, for one project you would have just one entry. Suppose this is project 1 and the number is suppose PO1, location is somewhere in suppose say Bonani, and the hours worked. Now how would you specifically indicate the hours worked for each distinct employee? Suppose you have 40 here as hours worked. So this is name, this is project number, this is location, and this is hours worked, right? So if you have 40 here, now how are you going to be able to say for sure who worked this 40 hours, or are these the combined hours worked by each employee? So you cannot say that. So there is some sort of ambiguity here, right? So this solution would not work. So now let's try a different solution where we instead put hours worked on employee as an attribute. Okay, so again, so I have employee here, so I'll write another table here for employee, and I have the following attributes, suppose name, SSN and hours worked, right? So suppose my employee's name is ABC, SSN is 003 and hours worked is 50, and suppose I have another employee ABZ whose SSN is 010 and his hours worked is 60. But you see, at the same time, just like we could previously have one project having multiple employees, we can also have this case where one employee can work on multiple projects. So that is why we had a MS2N relationship, right? So now you have hours worked 50 for employee ABC. So suppose employee ABC is my employee E1, and E1 works in 3 particular projects. So now how are you going to know how many hours he worked on each of these projects? You cannot say that for sure. Therefore, none of these approaches are going to work. So if I go back to the slide that we were using, so therefore it's saying that most relationship attributes are used with MS to N relationships. So when you have scenarios like this, you cannot have, so when you have a scenario where a specific attribute is dependent on both the entities, you cannot keep it as an attribute on the entities. You have to use it as an attribute on the relationship. So this would be the correct approach. I mean, let me use a different color for this. So hours worked. Okay, so hours worked as an attribute on the relationship is the right way to do this, because when you later learn about how to transform ER diagrams into, suppose, say, schema or basically tables in your database, you'll see how we can use this to keep track of which employee works on each particular project. So suppose if we had works on as a separate table, and it had, suppose, employee SSN and project number and hours worked here. So from here on you could know which employee works on which project. Suppose if employee E1, whose SSN is 003, worked on project P1, suppose, let's call this project P1, project P1 whose number is P01, and if you wrote 30 here, you could specifically say, oh, so employee 003 worked on project P01 for 30 hours. So that is why when you have MS to N relationship and you have a specific attribute which is reliant on both the participating entity types, you cannot keep that attribute on any entity. You have to place it on a relationship. However, in the case of 1:n relationships, they can be, I mean, these attributes can be transferred to the entity type on the n side of the relationship. So for instance, suppose you have our entity employee and a relationship works for and another entity department. So now say I have the same requirement that you need to store the hours worked by each employee on a particular department per week, say, for example. But we know already that n employees work on one department. So you can directly store hours worked as an attribute on the employee. So that is what it's saying. Suppose if you had this as an attribute on the relationship type, you could transfer it to the entity on the n side of things. So we'll look at examples which will make this transfer clearer. So I'll stop today's lecture here since it's getting a bit lengthy, but for your homework, what I want you to do is go to slide 6 and 7, read the requirements, and based on what you've learned so far, try to create the ER diagram from the requirements given below. So in the next class, we'll probably do a practice classwork on ER diagram. So you'll be given a scenario and you'll need to draw an ER diagram. So for the time being, practice the one that's on the slide.